Welcome to episode 9 of Physics Until I Get a Girlfriend. Today I'm going to be yapping about nuclear physics. When I say nuclear physics, you should be thinking of two things: nuclear and physics. Physics is the study of the physical world. So when I say nuclear, you should be thinking of the nucleus of an atom. An atom is comprised of two parts: the electron cloud and the nucleus. The electron cloud contains electrons, it's negatively charged, and the study of that is all chemistry. The nucleus contains nucleons, it's positively charged, and the study of this is nuclear physics. Fun fact is that the nucleus contains the majority of the mass, and the electron cloud contains the majority of the volume. A good analogy to that would be a planet orbiting around a star. The orbit is significantly larger than the star, but the star is significantly more massive than the planet. Similarly, the electron cloud is significantly larger than the nucleus, but the nucleus has significantly more mass than the electron. The nucleus is comprised of protons and neutrons. We call these nucleides. Protons determine which element it is, and it has a positive charge. The neutrons determine which isotope it is, and it has a neutral charge. What is an isotope? So if you have a given element, you can add neutrons onto it to make it heavier. Protons and neutrons have the same mass. There are two types of nuclear reactions: fusion and fission. I don't want to oversimplify it, but fusion is when you have two smaller nuclei and they get pressed together into one nuclei. And fission is when you have a larger nuclei and it breaks apart into two smaller nuclei. Note that in both examples, protons and neutrons are not created or destroyed. The only thing that really changes is how they're grouped up. Nuclear fusion requires immense amounts of pressure to occur. Most commonly, you find this in the heart of a star, and it would release a lot of energy, and that outward energy would counteract the inward force of gravity. The star would take hydrogen, it would fuse it into the next element, and then keep fusing all of its stuff into the next element, and when it runs out of fuel, it would no longer have that outward force to balance out the inward gravity. It would scatter all the elements that it just created across the universe, and a large amount of the carbon that you are made up of is forged in the heart of the star, and the same is true for gold, iron, and lead.
Enrique!
When it comes to fission, some elements are just unstable. They might just eject two protons and two neutrons, or a helium ion. This is also called an alpha particle, and the process of ejecting it is called alpha decay. And it does this so that it can enter a more stable state. Another form of decay is gamma decay. If you throw a neutron at a nucleus hard enough, it breaks it apart, kind of like a pool break. And that releases so much energy, that energy takes the form of a light wave, and it's a really high energy light wave. They call them gamma rays. And the last type of nuclear decay I'm going to talk about is beta decay. Look at this pile here. The amount of neutrons is a lot higher than the amount of protons. So a neutron will become a proton to balance it out. Because the amount of protons change, it went from carbon to nitrogen. So if a neutral particle becomes a positively charged particle, then charge was created, which is not allowed. So to remedy that, the nuclei ejects an electron. That electron is called a beta minus particle. This also happens in reverse. If the stack of protons is too high, a proton will become a neutron and it will eject a positron, which is a positively charged electron. That's also called a beta plus particle. In conclusion, nuclear physics is about the nucleus of an atom. It is comprised of protons and neutrons. Two nuclei can fuse, a nuclei can break apart, it can emit alpha, beta, and gamma particles. It could be natural or induced. The end.